Welcome to class Honors Physics. Good to see you all today. So today's when we're actually starting with our A group, B group split. And so today, we'll call it Wednesday, we're going to have our A group is going to be going to do our synchronous day. And then maybe the next class, Thursday, our B group is going to do the synchronous day. And that's what I'm going to go over right now. Okay, synchronous, asynchronous days. And then I'll do a separate video for the next one. So as far as this goes, got our planner here that shows you what you'll be doing on your synchronous day right here. And then you've also got your synchronous day and asynchronous day overview and the assignments that will be due on these 2 days. And don't forget our time goals that we're trying to go for is like 440 minutes per week. So again, we're just going to be keeping track of our time and using this to make sure that we have a good grasp on like, are we spending too little or too much time? And also to give me some feedback to see if I need to adjust the pace of things to make this work for you. All right, so let's go into the synchronous day today for this slideshow of this presentation, and then I'll do this asynchronous right afterwards. So today we are going to go ahead and have some of our groups, I'm thinking maybe about 3 or so, are going to present their This Is Me project on Zoom to the class. And I will just kind of go through a list and call people and be like, okay, it's your turn to do it. So you'll want to be ready, and you're going to want to have your presentation somewhere where you can then present it to the group. So we'll have that open up for you in Zoom where you can present. So that'll be our first thing. We're just going to do that over a period of time during the synchronous classes. Next thing we're going to do is we're going to review the math pre-quiz and the measurements assignment in partner groups. So the way that I'm going to do this one here is I'm going to have you guys actually do the review, look at the answer keys, do any corrections you need to in your journals, and work with your partners. And then I'm going to go in and out with Zooms where you can just pop in and ask me specific questions. But I want you to really just lean on your partners to try to help each other figure out like what were you doing during the math pre-quiz and the measurements assignment, and use that to study for a math quiz that we're going to have early next week. Okay. Excuse me. All right, and so next thing, a couple of things to note. As far as the math pre-test goes, some of the issues that we often see with these are we have certain conventions we want to meet in physics, and you should always calculate decimal equivalents and not fractions when you're reporting numbers in physics. So if you have the number is like 3 divided by 4, I mean 3 over 4 meters per second makes sense, but it's better to say 0.75. We're going to do significant figures later in the year, but you'll want to use significant figure rules when you report numbers too. Next thing is always want to show units. This is a big one that goes on in physics. People just write a number down and don't put units. I always need to see the units. Okay. Show all of your work. You'll find that I don't give credit if the work isn't shown. Oftentimes, if you just write down an answer, but it was like a whole bunch of work that got to that point, I don't want to just see the answer. I need to see your whole process. And that's one of the big reasons why we're going to do a lot of our work on paper, so I can actually see you write everything out and then take pictures and upload those, because I really do want to see how you think and how you work. Okay. When you get to your final answers, box or circle your final answers. I want them to be obvious. Sometimes when there's just a whole bunch of writing going on with numbers all over the place, I can't even find the answer, especially if it's not the right answer. So I need you to box or circle your answer. And then you want to use a formula when you solve problems. You always want to start by showing me the formula you're using. Show me the algebraic manipulation that got you to the point where you actually solved it. I want to see that whole process. Okay. All right, so again, working with your partners, you're going to be working on the corrections around the math pre-test and then also the corrections around measurements, and use this with your partners to study for the test next class. Once you're finished with that, you're then going to go into this idea of estimation, and we're going to do an assignment called a Fermi project. And so the estimation assignment looks like this. First of all, thinking what is estimation? Here's a picture of the globe, and if you notice right here, there is a certain distance from here to here. And if you wanted to figure out like from Los Angeles to New York, it's 3,000 miles. Okay. Based on that, and based on what you know about the look of the Earth, compared to that picture right there, could you estimate the circumference of the Earth? Okay, so this is like an estimation project. And down here in the speaker notes, you're going to find information here to help you out with that problem. Okay, so go ahead and look through that. And then you're going to jump into this Fermi assignment with your partners. Okay, so this assignment right here is going to be completed as a group project. And so I want to notice, like, first of all, we'll go ahead and get into Google Classroom. Let me pull that up with you. And let's get over to the Fermi project. And you're going to open up this link right here. And you're going to work through this project with your partners. You're only going to turn in one project in Google Classroom, and you're probably going to need to coordinate with your partners with like screen sharing and maybe using like a shared document and then copying and pasting into this document. But just one person in your group is going to be the point person, because this assignment is in Google Classroom and you're going to type directly into this assignment. And so what you're going to notice here is that it says all of your names and it's in blue. I want you to do all of your work in blue. You're going to start off with this scale of the universe assignment, and it's just like a real quick exploration. Now I just want to show you what it looks like here. So this is the scale of the universe assignment. You may find that your computer asks you to load Flash, and you want to do that. And if your computer is unable to load Flash, up here in the address bar where you type things in, you'll see it'll be like blocked, and there'll be like a little red icon up here, and then you can go ahead and click it and then go into your settings and enable Flash on your computer. And the idea is if you get this to load, you're going to have this scale of the universe program come up, and it looks kind of like this. Now listen to the music. It's got some real soothing music that goes with it. And this is going to give us an idea of orders of magnitude and sense of scale. And so notice right here, we're at the order of magnitude of 10 to the 0 power. And so this is going to be using meters as our SI unit for distances. But notice this little circle here is 1 meter. So that's like 1 times 10 to the 0 equals 1 meter. And notice that things that are in this order of magnitude are like us as humans. We're like 1.7 meters, or 1.7 times 10 to the 0 meters. We've got some beach balls, dodo birds, and anything I click on, it's going to give me not only its size, but it's going to talk about some facts about it too. And if I want to go ahead and see what's in the smaller world, I can zoom to the left here, and I can find things that are really, really small. Okay, so like here's an up quark, and it tells me all about an up quark. It's in the order of magnitude of 1 times 10 to the negative 18 meters. And I can go to the opposite direction and get in the bigger world too, and go all the way up here to objects like, here we are, like California's on there. Go further up here, different stars. Okay, getting up into some of the Ant Nebula. I want to find out about that. Oh, it's about 2 times 10 to the 16 meters wide. And so you're just going to go ahead and use this program right here in order to answer these questions with your partners. And notice if I just click, it's already blue. See that? You're just going to answer your questions in blue, you and your partners. Now, the next thing you're going to do is this Fermi problem. And Enrico Fermi was an Italian physicist who helped create nuclear bombs. And so he was like a smart physicist during World War II time frame. And he was famous for sitting down with his friends in like a cafe or something, and they'd be having a deep conversation about something. And he'd just have a question that would pop in his head, and he would like pull out an envelope and turn it over on the back, and then just start like writing down a bunch of assumptions and coming up with a bunch of quick calculations, and then coming up with these answers to these big problems that these physicists were talking about it. And everybody was always shocked at how he could just come up with these quick back of the envelope calculations that in the end turned out to be really accurate. So he was using like orders of magnitude and scale factors and just a common knowledge that was floating out there to come up with some pretty profound realizations. And so you're going to do something like this with your partners to start to play with these math concepts of estimation. And I had given an example Fermi question here. How much does a standard cumulus cloud weigh? Okay, so that's a hard one to get the answer for. But I made a wild guess. Then I made an educated guess by putting some numbers in it. I came up with a calculation approach. I gathered some information. I used Google to search different things. And then I came up with some estimations. Okay. And then I checked out and saw how my estimations worked out compared to what Google says. Okay. And that's kind of the process you're going to use. That was just an example. But notice here it gives you the directions of how to do this with your partners. And then it gives you the format here. And what you want to do with this format is take a question. You could use one of my many questions here, or you could come up with your own question. But you want to follow this format, and in this area, you want to fill in your information and then come up with your conclusion. So this is a group project. So again, you're just going to have one for your whole group. Okay, and you can collaborate. It's possible you could take copies of this and give it to your partners. You could work on different pieces and talk about it. But at the end, I just want to have one document for your whole group with all your names on it. Okay. All right, so jumping back into our slideshow for today. So that was our Fermi project. And that was it. That's the end of class. And then you have the daily reflection form to finish up. So have a great day, everybody. If you have any, this is our synchronous class, so we're going to kind of like have a little discussion in class around this, but then you're going to work with your partners to get this done. And have a great day. It's a great day to be a Lakewood Tiger. Rawr.